Safety critical components. Anything about enclosures? All right. So 4849, we're going to look at those. And there's a table, what is it, 8.10 for critical components. And so I want to look at that in the CB test report form. And then I want to show you a lot of examples, or quite a few anyway. All right, so 4.8 is that clause in the beginning, the general clause that kind of talks high level about what's required. And so after it talks about, you know, let's have risk management and let's identify essential performance and let's have an expected service life and an alternative risk control measure, and 4.6 for the you know, touch protection. 4.7 is single fault safe. We then have a 4.8 that talks about components, and all components, including wiring, the failure of which could result in a hazardous situation, shall be used in accordance with their specified ratings, you know, unless you don't want to, and your risk management's in agreement. It shall comply with one of the following: the applicable safety requirements for the IEC or ISO standard, the component standard, or B, or at least you only have to meet one. So there's kind of an exclusive or, but it could be both, where there is no relevant IEC or ISO standard, the requirements in this standard. So the general, you know, pass your basic safety and essential performance kind of stuff. So that's your generic IEC requirement. In fact, if you look at the US, Canadian, European CENELEC versions, each of those jurisdictions modify this clause. So this was A or B, right? So A says comply with the relevant component standard. And if you do, it doesn't say it in that clause, but there might be a flow chart as well. Where's the flow chart? Can you see that? Probably not. Relevant standard, no. Meet the end product, yes. Relevant requirements of the standard, no. Yes. Is the component, is there evidence? Yes. Additional safety requirements at 601. So while the clause isn't very clear, it is clear from the flow chart that the intent was you're always going to meet the standard generally, and then additionally the component standard, okay? So I've done that here. But anyway, say there's no relevant IEC ISO component standard. These three jurisdictions said, is there a relevant one for our jurisdiction? And if there is, you must meet it and the general standard. And if there isn't, then just do the general standard, okay? So I should show you that this is true, the gray. So here's what the Americans do in 4.8. The relevant ANSI standard shall be applied if no relevant ANSI standard exists, the requirements of this standard. So the gray is what the Americans added to B. In the Canadian version, the applicable safety requirements of the relevant CSA, IEC or ISO standard, or the B. And so they put a CSA in there rather than ANSI. And Europe didn't modify 4.8. They have a general NXZA the British like to say Z, of course, and the Americans like to say Z. And since it's Europe, we'll go with Z. ZA lists many HD harmonized document or whatever it's called. So there's a big list of components standards in Europe. And so this is the text that introduces ZA. Following documents in whole or in part are normatively referenced. Okay, normatively means it's required. All right, so so the idea is if there's a national version, you're going to meet it. And so within these three jurisdictions, if that's your market, you need to consider the gray part normative. 4.9 is this high integrity, so let's take a look at it. A component with high integrity characteristics shall be used when a fault in a particular component can generate non-acceptable risk. Components with high integrity characteristics shall be selected or evaluated consistent with their conditions of use and reasonably foreseeable misuse during the expected service life. All right. So most components, if they're safety related, are going to result in a acceptable risk, but we would have a backup. And so this says a component with high integrity characteristics shall be used when a fault in a particular component can generate non-acceptable risk. Components. Huh. Yeah, I've never liked this clause. I think it got worded wrong. You know, high integrity betrays a certain intent that it's this idea that it's reinforced insulation, a single means that has the equivalent of two means of protection because it has that same probability of failure. I wonder if there's a paragraph I left out. No, there isn't. Compliance is checked by inspection of the risk file and a selection of criteria. So what's interesting is I kick this around because I think there's two cases where this applies, not just one. So I think by the title, the high integrity, it betrays the intent that it's this two means because there's, you know, it's a single component, but negligible chance of failure. But when you read the text, you see two cases. That single component that's not going to fail, but also there's one component that did fail, and now we're talking about the backup component, and maybe that's the fuse or the over temperature device. And it seems to me that if that failed, you'd have an unacceptable risk, right? And so now it's not supposed to have two single faults, but it is true that if the backup failed, you'd have an unacceptable risk. And so, you know, you could argue that it includes those, which is no big consequence because nobody was going to have a fuse or an over temperature device or related safety catch mechanical that was somehow not safety related, not being compliant with a component standard. So I'm not sure there's a consequence either way, but it just bothers me that it's not that clear. Yeah. So just for fun, so 4.8's got a lot of good stuff here. Rambles on. Resistors. Oh yeah, everybody loves resistors. So there's not really any component standards for resistors as far as reliability. And so, you know, if it's 2 times the power it's ever going to see, is that okay? Probably. 4.9, use of components with high integrity. Yeah, type tests. You know, so you can see it's very reliability orientated. Yeah. Yeah. So to me, the intent is those, a single component that might not have a backup. And that's okay because it's high integrity. It's a negligible chance of failure. Okay. But there is a bit of rationale here. And so the intent wasn't necessarily to read all that to you. The intent is to show you a process. You read a requirement, you say to yourself, wow, that's all well and good, but what does it mean? And so you start reading this. The other thing you do is read the definitions, right? And the definition is even consistent with, so they're alphabetical, component with high integrity. So a component where one or more characteristics ensures that its function is fault-free in relation to the safety requirements during the expected service life. So this is pretty consistent with the idea that it's the single component that has the negligible chance of failure. And so in that process, and there's even rationale for the definition. So we could have even more fun. Okay. But that's the real world. You start with the requirement. Is the rationale going to help? Are definitions going to help? Okay. All right. Anyway, there's those two categories, and it doesn't really matter because in either case, they're safety critical. It does matter in that, geez, a component without a backup, shouldn't fail. So I certainly don't want to dismiss that very important concept. But there's generally component standards that provide that assurance. And if it was not high integrity, we'd also be meeting an appropriate component standard. All right, so so we know we want to use it within the ratings. And the standard does sort of say, well, but if you think it's good for something else and your risk process is good with that, that's okay too. But be very, very careful about that. Although the standard says that, I mean, how from a quality system point of view or a critical supplier point of view, can you really use something outside its ratings? Because the vendor is very interested in I hope, knowing that it's going to be safe within his ratings, their ratings. And yet you're trying to use it outside your ratings. What if he changes something and he knows it's still good within his ratings, their ratings, but how do you know it's still good within your rating? You don't. And so, the vendor agreement says any change, he's going to let you know. Yeah, but he's not. And so, you'd really be, in my opinion, in that situation, obliged to do like an incoming test. If there's some critical property that you think is important to maintain so that you can use it outside of his ratings, but within yours, you probably should be doing an incoming, or, if you want to bind your vendor to do his outgoing, but he's not going to agree or he would have rated it that way. Anyway, it's not just a matter of, oh, well, I tested it once and it's fine. It's not. It's only fine if it's fine forever. All right, you get the idea. So generally you want to, get your components already tested, of course. And so they're going to be certified by these third-party people. It's going to have a VDE mark, a UL mark, whatever you think's appropriate for the standard you're trying to comply with. And the data sheets will tell you that. You can go to third-party certification databases and find those things. And in the case of a power supply, you're probably going to want the test report, not just the certificate. So this is a link to my website, and I've got, in my day-to-day, and some of these links could be dead. I haven't used them in a while. But in my day-to-day, I would visit these sites. And so I put the links on a public page. But, they have searchable databases of components, so you can kind of independently verify what a data sheet says. 810 is the list of critical components. Maybe sometimes with photos would verify construction. So what goes in 8.10? So we end up listing especially mains components and then electrical isolation things would be that could be mains related. So I've said something redundantly, but it's not always mains. So sometimes you're separating secondaries and certainly floating applied parts from other earthed parts. So isolation in that very general sense. And the enclosure materials, enclosure opening. So that would be a core of what you'd expect to see in the 8.10 critical component table. And you as a manufacturer would have identified a much larger population of things that are critical, at two levels. One, because the equipment has to function, so that's everything. But perhaps a subset of that would be safety critical. And those would be identified so that you don't second source, third source without appropriate, change notice reviews. But then there's even a smaller subset, probably smaller, but overlapping with the safety critical within your own system, where they were in table 8.10. Yeah, so I think you can kind of think of it that way. And so this is table 8.10. You're going to see these columns. And there's your manufacturer and type number. Is that always safety critical? Sometimes it's necessary to confirm what was tested, but we have a means to say or equivalent, or UL puts it in parentheses sometimes. Not sometimes. That's UL's method for optional. More often, I think I say or equivalent. And then or equivalent, and in the case of UL's parentheses, you would still meet the ratings, if you will, this technical data header. And so the intent would be you have to make ratings. If there's a certification standard and mark specified, that isn't optional, yeah? But sometimes the manufacturer type number could be. Now, this is a power entry module, and this is the mains power supply. So these haven't been given that or equivalent, yeah? And what happens if that stays that way, if somebody's issued you that report other than yourself, you have to have them change that if you change your vendor. And so you want to make sure the test lab really intends that, of course. But they probably do in these two cases. They'll tell you, no, you need to talk to me if you change this, okay? So those are two examples, and so some good ratings here, and then in fact there's some component standards and third-party marks. There's an ODG 2060. I don't think I provided it with you. It's not that useful, but I probably should send it to you. Let me just make a note. I think you might be able to Google it and get it. Let's see. Maybe I can remember. I'm going to put it here. what is it? 2060. All right. It talks about interchangeability. And so that gets at that this whole issue of, do I have to specify the manufacturer and part number, and be bound to the need for a review if I get a second source, and if there is a need to be bound to the manufacturer and part number, think about submitting the second source while you're having the equipment tested, and so then they might say, well, this is worst case, I only got to test one, and give you both. Or they might say, let's test both, but at least you get it done. It's probably cheaper to get it done than to have it done after the fact. And it could be paperwork. So if you did do it after the fact and say, well, I know I used to use, Cosell's power supply. I've got this, who's another power supply guy? I'm drawing a blank. Geez. Anyway, I got these guys, and I just want to substitute it. It's the same ratings, blah blah. Yeah, they might want to test it. But there's another example where it could have been, actually an inlet. They might let you substitute it, but they'd scrutinize it carefully, or even the power supply. But they need to know it's not going to operate too hot and all these kind of other subtle issues. Yeah. All right. All right. And so this is the idea that, you're going to get your mains, and then there's probably less emphasis to include some of the casualty, ingress, radiation, risk controls. But the enclosures are part of 810. And in any case, you have your own controls for things. Just because they're not in 810 doesn't mean you're not going to control things. You need to do photos. You don't want to do a straight on photo. You want to kind of get the three-dimensional thing. And so there's some guidance I've summarized. Safety boards, you basically take a shot at the boards. So mains components would include the inlet, the Y caps, the on-off switch, the fuse holder. These modules are great, right? You've got everything in one little package, and checked for all those component standards. So I would certainly encourage that kind of thing. Wiring, here's an example of an entry that might be in 810, and it does say any here, or they would have specified, alpha or bell, what are they called? Belden, and then or equivalent, or so there's some ratings here, there's some certifications here, and it's meant to be very generic. So I just offer one example so that it's as flexible as possible. Connectors, again, I've sort of shown an example of something as flexible as possible. V2 flame ratings might be applicable. Boards, the bare boards, get the UL or CSA. And then there's certain ratings that'll be all right. These might have to be V2, right? Supply cords. So I've given an example of something as generic as I think you can be. Keep in mind, in North America, we have this little green dot thing. So this was the North American. This is kind of the EU HAR cord. And then there's a generic I see you, Greg. There's a generic, what is it, IEC? Yeah, 227 and 320. Yeah, Greg, you were going to say something?
Yeah, how you doing, Frank? Yeah, that power cord. I had Canadians tell me that, for a product rated 100 to 240,
Yeah.
That plug cap needs to be rated 250 volts. I have yet to confirm that, but do you
Yeah.
see where
Yeah.
they're going with
But,
that?
NEMA always rates things as 125 or 250.
Yeah, just a
So,
little like gotcha type of thing, like, oh, damn, I didn't really see that coming, but
well, so the plug configuration's rated for 125, but it doesn't mean this cord's rated for 250.
yeah,
So
right.
that implies that the plug is too.
I would say,
So
like I said,
you're,
I
yeah,
can't
I'd be
confirm or
careful. I
deny
think
the
you're going to
findings.
get caught in a catch-22 there. No, these cord sets are rated for 250. Well, all right. So maybe you don't have to argue that if it's detachable, because but it is rated that. But say you take a different approach that, well, of course, if it's for use at 240, they're going to have a different cord set. The plug's incompatible with 240 for North America, so they'll have to get a cord set for the compatible socket.
Right. Yeah, I would think so. I mean, I looked at my Dell power brick, and they have 125 volt rated plug cap on the AC side, of
Yeah,
course.
yeah, but that rating refers to the configuration, not the voltage that it's suitable for.
Yeah, right. So, okay. Yeah, I just thought that was interesting to get gigged on that after 25 years. But anyways,
Yeah,
okay, that's all. That's all. I just wanted to bring that up. Thanks.
yeah. Don't now you've invited me to digress. So one of my first years at BDE, I'm dealing with the 950 crowd, and they speak English great, so it's all good. But anyway, oh geez, Garrett, what was his name? Gerhard? Oh, yeah, maybe it was. So anyway, I think he had a thing. He sometimes looked at Americans with a less than favorable light, and so he had his finger out. He was giving me the finger. He had his little probe out, and he was half unplugged the American plug, right? And he put the finger right on the pin, the live pin. He says, "Geez, Frank, I don't think we can take this product at all." So this manufacturer, internal to the product, had used that for interconnect means from one module to another, and so but it's service, and he was criticizing basically the entire country for having a terribly unsafe plug and socket system. I'm like, yeah, okay. What was his name? Gondom. I think it wasn't Gondom. Garrett, no. Yeah, geez, it's terrible the way I forget things. Anyway, we'll go with Gerhard, and he was going to reverse 200 years of experience, but he didn't get very far. And it sounds like you're in a similar situation there, Greg.
Yeah, just
I
somewhat.
think
Seemed
you
like
can
somewhat an
show
advantage.
this. Yeah, I think it is rated 250 because I've run into that too. If you think about it, we're traveling all over the world and using a little, it used to be you couldn't get test labs to test those adapters, the 240 to 120 adapters that we use when we travel. Now, they all are safety certified now, but it used to be nobody would touch those. And part of the problem was this voltage problem. And so that may be what changed. In the 80s, they might have started to acknowledge that that needs to be good for 250. They are, Greg. I've had to figure it out. Anyway, these are bigger cords, so if it had been a bigger system, I would have had to write it up with some of these ratings and because of the wire diameter, I guess I included this. All right, so power supplies are always going to be specified. What do I mean? Sometimes they're external. Think about these plug-in ones, direct plug-in, no supply cord. These are kind of nice, these slide-on things. I think that's Freeman and Wolf. So keep those things in mind. They're awful handy. And then there's the internal ones. XP Power, there's an example of somebody. Specifying power supplies. Yeah, think about your second source. But this is, second source can be related to avoiding safety tests, but I meant for this to be the column that's not so safety related. But on the safety related side, you have that whole, what's my installation diagram say that's appropriate? And, in a sense, it's describing your power supply in that one barrier there, or the mains to chassis, mains to SIP-SOP. So that's your power supply. And so when you go to buy your power supply, you need to be specifying that installation type and voltage. And then as this says, think about your environment. You're going to operate it within your internal to the housing environment for temperatures. Are you going to need a fan? Do you need to put a fuse on there, within your product? And etc. Used within ratings. And here's the insulation issues. Okay. F-type applied parts, you're going to have a DC to DC. So here's the three basic power supplies, if you will. There's kind of two basic types, and then we should try to talk about this hybrid. So this is a pure medical patient protection power supply. And so that's generally what we mean by a medical power supply. I've got my medical leakage I like. I got my patient protection that I like. Means to SIP-SOP, it would be two means. Means to a protective earth, it'd be one. And then I've got my computer power supply. They would comply with 61010 as well. It's going to meet the computer-related leakage and the computer-related insulation. And then we saw 4.6 would allow us to use that insulation in our MOOC situation. And yet we have to have medical leakage. And so this is sort of this could be a gotcha. You can't just buy this guy and think he's giving you this. But if you were careful about what you're specifying, can you give me this power supply, but you might have to change the inlet, the EMI filter. And do you know what I'm talking about? Can you give me that? Oh, yeah, I know exactly what you need. Good, here it is. Okay. Relays, optocouplers, high-speed USB, you're kind of looking at these magnetic or whatever magic is used to provide isolation at high speed data transfer speeds. So there's old-fashioned relays with a switch in there, switch gaps. You've got your solid-state relays, but in any case, there's separation, and there's separation, and those should comply with component standards that are appropriate. Okay, and then just make sure it's consistent with your insulation diagram. Here's your other. So your enclosure, the wiring, connectors, boards, an insulating sheet. Think about transistors mounted to a heat sink. Think about a board mounted with a sheet under it. Some of that's critical. It might get picked up on 8.10, the table. Certainly, all your overcurrent, over temperature protectors and batteries and the battery protection. I would expect to see that on table 810. All right. Any questions? That can be an interesting topic sometimes, I've seen.
We have a critical component list for one of our products where the test lab put on software. Have you ever seen
Was it
that before?
UL?
It was not UL, it was CSA. But it's kind of been a nightmare, and it's only one of them.
So the thing is, so configuration management, you usually have the 3.0.0 or something, right? And so when CSA wants to specify the version, you would have to agree, if that's what they want. But the pushback is more, well, if you read my configuration management, when we change this rev in a lower hierarchy, it's not really safety related. And so, we should have an X here. So it could be 3.0.x, for X can be any number. And I don't know, but that's got to be your strategy. You know what I mean? Yeah.
I think so.
If you're doing well, so I mean, his pushback might be, yeah, I don't care if you fixed a bug that had nothing to do with nothing, but how do I know when you fixed that bug that you didn't mess up the whole thing? So you would need to be able to answer that question. Well, that would never happen.
Exactly.
So in some ways, he's going to be forced to admit that you do follow your procedures to some extent, because he could always argue that any level is critical and I need to be notified. But, he needs to think about being contacted. If it's CSA, they show up once a year. Are you on category certification or?
Yeah, they come in every quarter, but they only pick one of our products.
Yeah. Okay. Yeah, I see. Yeah.
But
so
never
what I was
asked.
going to say is that you would never send anything to them. They just come to you, whatever they do, and they review it then. So whether he specified that or not, he's probably going to want to ask you about your software when he shows up. And
they never have actually. So I no.
Yeah. So this is it. So 8.10, to what extent, the test labs are busy. I suppose if they weren't busy, they'd want to make work, but they don't want to make work because they are plenty busy. And, there's only so many competent compliance engineers that these people can hire. So the pipeline's only so wide. And so there's a need to prioritize. And that's why 8.10 is small, because I just don't want to be bothered unless it's related to this. And maybe software, because it's a process review, maybe we should rely on, the fact that notified bodies and the FDA and whoever else might be involved is looking at your, auditing your processes. And maybe the rev. This would be an area where I'd want to document what was reviewed, but we wouldn't want to necessarily stop you from shipping something that evolved at a certain level without having it been reviewed by if I was your third-party test lab. So I would just try to discuss those concepts with them and get less control. But that's a great example.
Yeah, thanks.
Yeah. Anybody else? Hey, there's Greg. Hi, Greg.
Yeah, hey, sorry again. One area that what the gentleman just mentioned that I've seen come up is like isolation devices going not available due to this supply chain thing, and people have to do hardware changes right now to boards and things. I think so. Something for folks to be aware of. to try to design for multiple footprints and things of that nature going forward. But
oh boy, yeah, related to all those chip shortages.
yeah, seeing it a couple of different places.
Yeah.
And then those follow-up inspections could get tricky if they pick for the right stuff.
Yeah.
Digital isolator or something of that nature. But
yeah.
well, that's all more bad news. But
or good news, Greg. You're kind of related to the test lab that doesn't need more work than you already have. But yeah, I guess that's why it's bad news. Anybody else? It's 2 hours. How about that? What fun.